So this problem, it says the volume of a cone is increasing at a rate of 28 pi cubic units per second. At the instant, as soon as I see rate, I think, oh, I wonder if this is a related rates problem. Okay, and related rates has those things like for example, this one is what's increasing? The volume's increasing, so that means we have a dV over dt. What is a dV over dt? That is 28 pi. So that's one of the rates. Sorry, I had to pause and say it really quick. So I know this is probably going to be a related rate problem. So that's the rate that the volume is increasing. It's increasing at a rate, so it's a positive rate. At the instant when the radius r of the cone is 3, so it's giving me another value. When I have a radius of 3, its volume is 12, so I'm going to write that. Volume equals 12 pi cubic units, and the radius is increasing. Look, the radius is increasing. That's another rate at 1/2 unit per second. So how do I write radius is increasing? Like, how do I write that rate? For volume, it was dV over dt, so how do you think radius would be written? Yeah, dr over dt. So that equals 1/2. Alright, so I'm going to kind of box these together because they go together. This is one situation when r equals 3, the volume is that, and the rate is that, the rate of the radius. Alright, so now let's actually get to a question. That's just understanding this and kind of decoding the problem. At the instant when the radius of the cone is 3, hey, I know that, let's sort this stuff right here. What is the rate of change of the area of its base? What? Area of its base? Did it talk about an area of a base up here at all? No, it didn't. But it was talking about a cone, and if I think about a cone, you can draw a cone upside down, or you can draw its right side up, whatever. What's the base? It's this circle right here. Do you guys know how to find the volume of that circle? Not the volume, sorry, the area. What's the area of that circle?
Pi r squared.
A equals pi r squared. And so now we have an equation for the area. It says at the instant it's of 3 units, so I know that the r is 3 units, but I'm not going to plug it in yet. What is the rate of change of the area of its base? Now, what I want to know is how the area of the base is changing. What is how would you write the rate at which the area is changing? This is the rate at which the volume is changing. This is the rate at which the radius is changing. How would you write the rate at which A is changing? dA over dt. So this is what we're looking for. We're looking for a dA over dt. Now, how would I get dA over dt? Well, you'd have to take this and this whole equation and take the derivative of it. Because right now, all I'm trying to do is I'm trying to get this in my equation somehow, so then I could solve for it somehow. All right, so what we're gonna do now is we're gonna take the derivative of this with respect to dt. Okay, so t is always time. Related rates always uses time, and that's what these rates are for too. Like they're with respect to time. So I'm gonna take the derivative of a and the derivative of r with respect to t. When you do that, you're pretty much implicitly deriving with both these variables. So if I took the derivative of a, that would just be 1, but then you would have to multiply it by dA over dt. Equals, now the pi is like a constant, so don't worry about him. Just look at r squared. If you took the derivative of r squared, you would take that 2 and multiply it times the pi, so you get 2 pi, and then you would take 1 away from the squared, right? So because this is a squared, I still have an r right here. But what am I supposed to multiply it by after I take the derivative with respect to t? dr over dt. Okay, so I took the derivative, this is what I got. Now I have this equation that I can use to find dA over dt. So d over dt is what I'm trying to find. Do I know what r and what dr over dt is?
Wait,
Yeah.
why are you multiplying by 0 over dt?
Wait, say that again?
Why are you multiplying by 0 over dt?
Because whenever you implicitly derive something, you always multiply it by the derivative of that. Like, so like if I was, let's say I had x plus y equals 2. If I want to take the derivative of this with respect to x, I would go, the derivative of x is just 1, right? That's the easy one. But what about the derivative of y? Well, derivative of y, let's just treat it like normal. It would have an exponent of 1. You would drop that, and then you take 1 away from the 1, right? So then it would be y to the 0 power. What is y to the 0 power? That equals just 1, right? So we have the derivative of y, which is just 1. But then we have to multiply it by dy over dx.
Oh,
Because you're assuming that the y is a function of x, since we're taking the derivative with respect to x. Alright, so let me get rid of all that now. So that's what we're doing. We're implicitly deriving when we're doing related rate problems. So, do I know what r is, and do I know what dr over dt is? Yeah, I do. Look, check out the problem. R is 3, and when r is 3, we know this. The rate is 1/2. So we just got to plug that stuff in. So we have 2 pi, and r is 3, and dr over dt is 1/2. Oh, I love it when I get to simplify, or like plug stuff in. Everything looks all simple again. So now dA over dt, the change of the area, the rate, is equal to this. 2 times 1/2, those go away, and I'm left with 3 pi equals dA over dt. I'm going to write that on the side because I'm going to erase stuff, and I'm going to use that later. Maybe. I don't know. So dA over dt equals 3 pi. And actually, I should put that in my box. So he's part of the box.
it's not a box thing.
Yeah, it's not a box anymore. All right, let me erase that work. Actually, let's leave it. See if I need it. Sorry, I have to repeat stuff when it's on the video. All right, so B, at the instant when the radius of the cone is 3, what is the rate of change of its height? Huh? Do we see a dH over dt over here? No, I see the rate at which the volume is changing, the rate at which the r is changing, the rate at which the area is changing. This says I need a dH over dt. So now I'm looking for a dH over dt. Do we have an equation anywhere in this problem that has an h in it?
No, the volume.
Yeah, it's right here. The volume has an h in it. Okay, so let's write that down. We're looking for dH over dt. If I have V equals 1/3 pi r squared times h. Now there's a couple things you can do here. We can get rid of the r, so we only have an h here. Or we can take the derivative of it as it stands. If we took the derivative as it stands with respect to t, we know we're going to get a dv over dt, and we know we're going to get a dr over dt. Do we know what dv over dt and what dr over dt is? We do. We're given those right here. So you don't need to get rid of the r. You don't have to do it that way. We can leave it. But the problem with leaving it, because I can see into the future, if I take the derivative of r squared times h, I want to use the product rule. And I don't want to do the product rule. Plus, I really want to show you guys how to get rid of that r. So if you want to just continue it right here, it will work. Just make sure you do the product rule with the r squared plus r times h. But I'm going to get rid of that r before I do the derivative. So what we're going to do is we're going to see how is r related to h. Never mind, can't do that because they don't give us an original height, so we can't do that way. So we got to do the product rule. Oh well. So if I take the derivative of v, it's going to be dv over dt equals, and what I'm going to do over here is I'm going to take out the pi over 3 and not worry about him right now. Inside of my parentheses, I'm going to do the product rule with r squared times h. Alright, so the derivative of r squared is going to be 2r. But then I have to multiply it times dr over dt. And then I multiply it by h. Then we're going to go plus. So that was the derivative of r squared times the second. Now I'm going to do the derivative of h times the first. So the derivative of h is going to be 1 times dh over dt. And we're going to multiply it times r squared. Okay. And then, so this is what dv over dt is. And what are we looking for again? dh over dt. So do we have all of this information? Do we have a dv over dt, an r, a dr over dt, an h, and an r? I know we have an r. What's r equal? R equals 3. So I can plug in an r right there, and I can plug in an r right here. That's 3. Okay, I don't know. Is that visible? I think that's visible. Do I have a dr over dt? Yeah, he's right there. He's a 1/2. So now I have to plug in dv over dt, which is going to be 28 pi. So this is 28 pi. Oh, that's a great pi. Now the only one I'm missing is the h. So I'm gonna write out what we have just to kind of clean it up, but we're gonna have to figure that part out. So we have 2 times 3 times. Actually, let's multiply that out. What's 2 times 3 times 1/2? Well, 2 times 1/2 is 1, so we get 3 times h plus dh over dt, and then we have a 9 times 9. Alright, so we can't find dh over dt until we get rid of that h. Alright, so how am I going to find the h? Well, if I know the radius and the volume at a certain point in time, then I can find the h. Do we know the radius and the volume? Oh yeah. So we're going to plug those in. So it's going to be, let's see, the volume is 12 pi equals 1/3 times pi. I'm just plugging in the radius now, 3 squared. And that's going to be multiplying times h. So let's simplify stuff. That's going to be 9. 9 times 1/3 is going to be 3 pi times h. H is going to be 4, because I divide both sides by 3 pi. So now I can plug in 4 for this h. Oh, man, all that work. Alright, I need more space. So let me see. What am I going to erase? Let's erase these guys over here. Don't need them right now. Okay, so if I rewrite what I have right here, I'm going to distribute this pi over 3 at the same time. Alright, so this is 12. And so 12 times pi over 3, let's see, let's go 28 pi on that side. 12 times pi over 3 is going to be 4 pi, because the 3 would cancel out with the 12 and become a 4, plus, and then I have to multiply pi over 3 times 9, which would give me a 3 pi, and I have dh over dt. Then I would subtract 4 from both sides, so this is going to be a 24 pi now, equals all that stuff. And if I wanted to get dh over dt alone, I had to divide by 3 pi, so I'm going to divide this by 3 pi now, which would give me 6. So 6 equals dh over dt. Actually, not 6, 8. That's right, 24 divided by 3 is 8. A dork. Alright. Now this last question gets most because it's hard to understand what it's asking. Alright, let me erase stuff really quick. And then we'll break it down a little bit. Okay, so this says at the instant when the radius is 3, so we're still using all this information. What is the instantaneous rate of change of the area of the base with respect to the height? Now, if you remember, before we had the area of the base, and that was a equals pi r squared, right? Well, when it says what is the rate of change, let's see, what is the instantaneous rate of change of the area with respect to its height? So that would be h. So we're taking the derivative with respect to h now. So to do that, we're going to get dA over dH equals, and now I got to take the derivative of this with respect to h, which is kind of weird. We get 2 pi r dr over dh. So what we need is, we need dA over dH. So we're going to have to find these variables right here. We have the r and the dr over dh. The r is no problem. What is the r?
3.
That's just 3. So we have 2 times pi times 3. But what's this? How are we going to find that? That actually is the same as dr over dt divided by dh over dt. Because when you think about it, if I were to divide those, it would be dr over dt times the reciprocal of this. So dt over dh. And if we treat these like regular fractions, these would cancel out, and we would get dr over dh, right? So do we know what dr over dt is?
Yeah.
It's 1/2. So we have 1/2
Oh,
divided by, and then what's dh over dt? 8. Divided by 8. So what is 1/2 divided by 8? Think about multiplying by the reciprocal. So we're going to have 1/2 times 1 over 8, which equals 1 over 16. So this is just 1 over 16. So we got 6 pi from 2 times 3, and then we're multiplying it by 1 over 16, which will then simplify to, let's see, that'd be 6 over 16 pi, and that would be 3 pi over 8, which is what dA over dH. That's it. That would be your answer.